So today I'm going to talk to you about a number of principles that we expect our younger mathematicians to be concrete in. Now, the first one is the one-to-one principle, and that basically means that the children can say the numbers of objects and keep track of the objects that they have counted. So, for example, 1, 2, 3, 4, 5. Now, in order to be successful at this, children must understand that every single object counted must have a number name allocated to it. They need to be able to recall and apply those names one at a time while physically keeping track. So they must be able to count in order, so in this case up to 5, while touching the objects that are being counted. This prevents situations like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there are 10 of them. We see that quite often. So children must know that every time they say a number, they touch an object. That's 1 object, 2 objects, 3 objects, 4 objects, 5 objects. It also means that children need to be aware of the items that have already been counted, and this prevents situations like this. 1, 2, 3, 4, 5, 6. They must know that they've already counted that one and to ensure that they get the correct total. And finally, they must also know that the names being given are specifically for counting and are nothing to do with the item being counted. So it doesn't matter whether they're counting 5 blocks, whether they are counting 5 magnets, or whether they are counting 5 paper clips. You would use the same kind of names each time. For example, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So even though the items have changed, you still use the same number names to count those objects. So in order to support children with the one-to-one principle, they must be confident in the principle of ordinality. Now, this basically means that children understand that when they count, the number names should always be in the same order. So when counting 1 to 5, they would always count 1, 2, 3, 4, 5. Now, when children first begin to do this, they will always count in a string. So they will have to go back to 1 and count again. So if they were counting 5, 1, 2, 3, 4, 5, and I then added 3 more, they would have to go back 1, 2, 3, 4, 5, 6, 7, 8. However, once children progress in this principle, they can begin to use what is called a chain. So they would go 1, 2, 3, 4, 5. When 3 more are added, they don't need to start at 1 again. They can start at 5 and count 6, 7, 8. Now, children who have progressed from this can say which number comes next. So they can begin to say what is 1 more than, what is 1 less than. And that is because they can start counting from any number. They don't have to start counting from 1. In order to support children in learning the one-to-one principle, as well as being concrete in ordinality, they must also be concrete in the cardinal principle. Now, this basically means that children recognise that the number associated with the last object touched is the total number of objects. So, for example, 1, 2, 3, 4, 5. The last number of the object that I touched was 5, so there are 5 in total. Recognising this principle means that the child understands that the earlier numbers were simply temporary steps towards the last number. And this means that children know that counting has a meaningful purpose, in this case to find the total number of blocks on the table. Children who struggle to distinguish ordinal from the cardinal may, when asked for 3, give you the 3rd object rather than 3 objects. Counting out a number of objects from a larger collection shows that children fully understand what cardinality is. Now, we wouldn't use the name cardinality with our children. However, we would give them plenty of practice. Can you give me 3 blocks from the 5? Can you pick out 2 teddy bears? Can you get 4 pieces of fruit for you and your friends? Having lots of examples of this on a day-to-day basis really means that the children become secure in the cardinal principle, which is essential for when they begin to carry out addition by counting on a number line. Children must be able to understand something called the abstraction principle. Now, this basically means that the principles of counting, so the one-to-one principle, the ordinality principle, cardinality principle, they are all applied to anything, irrespective of the size of the object, the appearance of the object, if they can touch it or not. So, for example, can you count the number of stars? Can you count the number of clouds? Can you count the number of planets? We can't physically touch those items, but we can still count them, and the exact same principles apply. It may be that children don't think that they can count something because it looks different to something else. So if I were to say, can you count the number of objects on the table? They might only count the magnets, for example. It may be that they want to count the magnets as more than the paper clips because they're bigger. However, they need to understand that it doesn't matter the size of the object or what the object is, it's still only counted as one object. In order to allow children to become really secure in this principle, we need to give them a lot of practice counting items with different variations in material and counting items that they can touch and they can't touch, particularly in getting them to count items in their imagination. That's a really good way of getting children to understand the abstraction principle. So finally, once the other 4 principles have been mastered, children then need to understand the order irrelevance principle. And this basically means that when counting, the order in which the items are counted is completely irrelevant. As long as each item is counted just once, the same total will be reached. Now, this principle completely relies on the secure understanding of the previous 4. And it's necessary as it allows children to generalise the use of counting flexibly as a tool without having to put things in a line. So one thing that we commonly see is if children have an array of objects like this, the temptation is to put them in a nice straight line, and then they feel that they can count them 1, 2, 3, 4, 5. However, as soon as children know that it doesn't matter how the objects are represented, there are still 5 of them, whether it's like that, whether it's like that, whether it's like that, there are still 5